The BCA Hub video series brings together the latest video tech tips on wheel hubs, bearings, and seals, featuring the experts you trust. Brought to you by BCA Bearings by NTN.
Now that we know what a wheel bearing is and what it does, let's go ahead and take a look at how to diagnose a failed wheel bearing and the components associated with them. This vehicle has a noise while driving. Let's go ahead and take her for a spin. Remember, the first step in any diagnosis is to verify the concern. Now that we've got through our test drive and got our vehicle lifted up on the air, we want to take a look at the tread on the tires, kind of running our hand over it, making sure it's not cupped in both directions. Right now this tread is very, very smooth. However, if you did have some cupped tires, you'd feel some waves in the tread itself, maybe going one way or the other depending on how you run your hand. Keep in mind that a really deformed or cupped tire can mimic or sound like a bad wheel bearing due to the fact that the tire itself is not rolling evenly on the tread or on the pavement. So next we're beginning our inspection of the front end to make sure that there is no excessive play or determine if there is play. That could be an indication of a failed wheel bearing. I'm going to kind of go back and forth from 3 and 9 position, seeing if there's any abnormal play. And then I'm also going to do the 6 and 12 position, kind of pushing in and pulling out a little bit to see if there's any play on this bearing that could be an indication that it has failed. Keep in mind this sometimes will help determine which side the wheel bearing has failed. If you're having a tough time figuring out if it's left or right, using a stethoscope and comparing left to right noises should help you determine which bearing has failed. Before I take the tire and the wheel assembly off, I do like to compare and contrast the left and the right sides. A defective wheel bearing that has some growling or grinding will usually transmit as you rotate the tire and can be felt in assemblies such as the control arms or the strut assembly if it's a front wheel drive. So I like to compare and contrast to verify the side that it is bad. So right now I'm going to check the right side and then we're going to move over to the left side and check and verify. Usually you can tell which one is bad just by sometimes feel. Sometimes a wheel bearing can fail, but give the driver no audible indication of this happening. Steering will feel normal, car will track straight, and no abnormal or growling noises can be heard when steering or driving. So what would alert the driver to a concern? The answer is warning lights illuminated on the instrument cluster, such as an ABS warning light, brake warning light, electronic stability control, or traction control lights could be on, warning the driver of an issue within one of these systems. Many bearings on today's vehicles incorporate a speed sensor inside of the unit that can be used by any and or all of the systems I had just mentioned. And these sensors cannot be serviced separately, so the entire hub bearing assembly would need to be replaced if failure of the sensor has been diagnosed. Let's go ahead and take a look at how to diagnose these speed sensors. First, let's see if there's any DTCs, or diagnostic trouble codes. Using a scan tool, we'll choose the appropriate module relating to the warning light on the dash. In this case, the ABS light, or anti-lock braking system, is on. So we'll go into the ABS module and see what kind of codes we have. In this case, we retrieved a DTC for left front wheel speed sensor signal lost. This means that the ABS module cannot detect the speed of the left front wheel and cannot accurately apply anti-lock braking without this information. This could affect any other system on the vehicle that needs to know the left front wheel speed. So next, before we actually start diagnosing any concerns, let's see if there's any TSBs for this vehicle relating to this concern. A TSB, or Technical Service Bulletin, is information posted by the vehicle manufacturer that is typically a result of numerous vehicles with the same unexpected occurrence or fault of a given part or system. This process can save technicians troubleshooting time, provide specific repair procedures, and standardize the repair process. So it's a good idea to get in the habit of checking for TSBs as part of your diagnostic approach. Nothing worse than spending hours diagnosing a problem only to find out that there was a TSB out there that would have saved you a lot of time in the repair process. So after searching for any TSBs, there wasn't any related to this vehicle concern. So we'll continue on with our diagnostics. Today's scan tools are more sophisticated than ever before. They can provide a technician with an enormous amount of information right at your fingertips. Not only can we check for DTCs, but some have TSBs, repair information, and even known fixes from other technicians loaded into them. Lab scopes and oscilloscopes are also becoming features built right into them as well. For this diagnosis, we're going to take a look at the data stream, specifically the wheel speed sensor data. This shows the perceived speed of each wheel while driving. All these values should match. All right, let's go take it for a drive and see what the wheel speed sensors are reading. And you can see right off the bat that all of them are reading the same except that left front, which is reading a consistent 0 miles per hour. You can also conclude that that is the reason why our ABS and traction control lights are on, because they are no longer able to read and understand what that left front wheel speed is. So now that we've driven that and verified that, we can move on to actually diagnosing it and verifying that the circuit's okay, or checking the circuitry and the wiring and the connectors. Next, let's go ahead and inspect the sensor, the connector, and wiring for damage. So we're back in the shop right now after our little test drive there to verify this and check the data that showed our left front wheel speed sensor signal was reading 0. So I've got the tire off here, and what we want to do now is go ahead and take a look at the wiring and do a little bit of a visual inspection before we get out any other tools we may need. So you can see the wiring right here. It runs down to the sensor over here, and it runs up and back through and around through, and it goes, looks like the connector is back behind this inner fender, so we're going to want to get access to that and remove that bolt, which will allow us access to the connector itself. Remember, a good thorough visual inspection is one of your first things you should do in any diagnostic approach. And then I'll peel this back. So again, we've got our inner fender back a little bit so we can gain access to the connector here. And you can see the connector is right here. Always want to make sure that you have a good tight connection and that there is no signs of any damage before you begin your testing. As you can see, I'm looking at the connector and it is engaged, and I don't see any signs of damage to the connection itself. So we're going to want to move on to our next phase of diagnostics. And after looking through the service manual and the service information provided, we're going to want to ohm test this sensor and see what it reads. I checked my connection and it was good. No obvious signs of any damage that would be causing the concern that we had with our ABS light. After reading through the service information, it is recommended now to ohm test that sensor, each individual circuit of it and the sensor itself, to see if any of it's open. I have grabbed my DVOM out, and again, you want to make sure when you're checking your leads that they're in the correct position. I have the red one on our volt and ohm meter section, and we have the black on our comm section. It's pretty easy to identify when you take a look. Comm is there, and then our red one is also over there. I'm going to select ohm meters at this point because we are ohm testing this circuit. Ohm testing is going to be checking for the continuity of that circuit, which also means, is it intact? All right. Turn down my ohm meter. Right now it's saying OL, which means over limit. Or also, and sometimes as a tech will say, if that circuit is, you see OL, it means out of luck. But right now we have nothing hooked up. So I want to verify that my meter is reading correctly. So I'm going to touch the two leads together and kind of let it get down to a reading that's acceptable. So I have verified that my meter is reading correctly. So now we're going to go through the diagnostic procedure to test this sensor. The diagnostic procedures, it has us check the connector side of the sensor. We're going to go from one side of the circuit to body ground and make sure that we do not have an open circuit. And right now you can see that we are showing some resistance, which is what indicates that the circuit is complete. I'm going to switch to the other wire in this connector, which may be a little difficult to see, and I've got another circuit that's showing that it's complete. So now I'm on the other side of that circuit. It's showing the continuity as well, meaning that the circuit from the connector to the actual ABS module is intact. Last thing we want to do is go ahead and check the continuity across the terminals of our wheel speed sensor. We got two wires right here, and we want to check the continuity across the sensor itself. And they recommend us go ahead and checking the ohms between both terminals right here. So we're going to go ahead and gently check that. All right, so we're go ahead and ohm testing the circuit. It is disconnected as it should be for an ohm testing. We went across the two terminals on the sensor itself, and if you look at our voltmeter, it does show OL, which means there is no continuity. The circuit is not complete on the sensor, which verifies that the actual sensor itself has failed and will need replaced. After performing diagnostics, we have determined that the wheel speed sensor has failed and will need replaced, which also means we will need to replace the hub bearing as this sensor is integrated into the bearing. One thing to keep in mind that some speed sensors receive voltage to them for them to operate. These are called active sensors and will have more wires than just two going to them. These sensors require a different testing procedure than a passive style speed sensor, which we have just shown. Remember to always check the service information for the testing procedures for the vehicle you are working on. Now that we've diagnosed that we need to replace this hub bearing, let's go ahead and see how that's done.